Today we will be discussing standard costing as applied to overhead variances. If you haven't watched the video on standard costing for direct materials and direct labor, I advise that you watch that video first, as the overhead variances are similar but a bit more complicated. A company's total overhead variance can be broken up into variable and fixed overhead variances, which can be broken up into two additional variances each. We will begin with the two variable overhead variances. First, we have the spending variance for variable overhead. This happens when there is more or less spending on variable overhead than budgeted. Maybe the standard rate is $2 per direct labor hour, but the actual spending is $2.05 per direct labor hour, creating an unfavorable variance. Second, we have the efficiency variance for variable overhead. This occurs when the budgeted amount of the allocation base is off. Maybe 1,080 labor hours were used when only 1,100 were budgeted for the number of units produced. This variance is about how efficiently or inefficiently the allocation base, in this case labor hours, are used. Next, for the two fixed overhead variances. Fixed overhead also has a spending variance, which occurs when there is more or less spending on fixed overhead than budgeted. There is also a fixed overhead volume variance, which occurs when there is a difference between the expected and actual production volume. Maybe the company budgeted to produce at 70% of capacity, but actually produced at 60% of capacity instead. Let's take a look at an example. First, we will look at the two variable overhead variances, and then we will look at the fixed overhead variances. Here we have an example related to a company that produces picnic tables. They used 1,100 labor hours to produce 540 picnic tables. The actual variable overhead costs are $2,100. As for standard costs, the company budgets $2 of variable overhead costs per direct labor hour, and each picnic table is budgeted to require 2 direct labor hours to produce. Our goal is to calculate the total variable overhead variance, and to determine how that variance is split between the spending and efficiency variances. The first thing we need is the actual variable overhead, which we are given here to be $2,100. Typically, this number will be given, but technically the formula to find the variable overhead costs is AH, the actual hours used, times AVR, the actual variable overhead rate. We will come back to this formula in a minute. The next thing we want to calculate is the budgeted variable overhead costs, found by taking the actual hours, AH, times the standard variable overhead rate, SVR. The actual number of direct labor hours used is 1,100, but we must multiply this by the standard variable overhead rate of $2 per direct labor hour, which gives us $2,200. Now I want you to notice the difference between these two formulas. Both values use the actual hours, but one multiplies by the actual variable overhead rate, and one multiplies by the standard overhead rate. In other words, we have held hours constant and allowed only the overhead rate to vary. When we let only the overhead rate to vary, we get the spending variance when we subtract the two values. 2,100 minus 2,200 equals $100 of spending variance. We don't write negative or positive signs, but instead we label the variance as favorable or unfavorable. You can verify that this variance is favorable by solving for the actual variable rate. If you take the $2,100 of actual variable overhead costs and divide by the 1,100 actual labor hours used, you get approximately 1.91, which is the AVR, the actual variable rate. This rate is lower than the standard rate of $2, meaning that the company spent less than budgeted on variable overhead per direct labor hour. Spending less is a favorable result, which is why we label this variance as favorable. Next, we need to calculate the applied overhead, which is equal to the standard hours, SH, multiplied by the standard variable rate, SVR. The standard hours are the amount of hours that should have been used to create the number of units that were produced in the period. The standard hours can be found by taking the 2 direct labor hours per table multiplied by the 540 tables produced, which is equal to 1,080. This can be multiplied by the $2 standard variable overhead rate to get $2,160. Sometimes this amount is given on a report like this one here. The company budgeted to produce at 70% of capacity, but actually produced at 60% of capacity, which we can see because 540 tables were actually produced. The associated budgeted variable overhead is $2,160, which is the amount applied at the $2 per direct labor hour rate. We are trying to calculate the efficiency variance now, meaning that we must hold the standard variable rate constant. You should notice that these two values both multiply by the standard variable rate, keeping the overhead rate constant. But the number of hours changes from actual to standard. That means that the difference between these two values is the variable overhead efficiency variance, which comes to be $40 unfavorable. Why unfavorable? Because the company used 1,100 direct labor hours when the budgeted standard suggests that only 1,080 should have been used. The company wasn't quite as efficient with the direct labor hours as they should have been, based on the standard. If you have set your problem up exactly how I have here, there's a quick and easy way to determine if the variances are favorable or unfavorable. Increasing from left to right suggests a favorable variance, and decreasing from left to right suggests an unfavorable variance. For example, from 2,100 to 2,200 is an increase, which makes the spending variance favorable. From 2,200 to 2,160 is a decrease, making the efficiency variance unfavorable. Finally, we can calculate the total variable overhead variance by subtracting the spending and efficiency variances. We subtract them because one is favorable and one is unfavorable. Otherwise, we would add them together. 100 minus 40 is equal to a $60 total variable overhead variance, which is favorable. When one variance is favorable and the other is unfavorable, the total variance has the same label as the larger variance, which in this case is the $100 favorable spending variance. Now let's take a look at how you would calculate the fixed overhead variances for the same example. The company is still producing picnic tables and produced 540 during the period. There were $1,260 of actual fixed overhead costs. Each table requires a standard of 2 direct labor hours to produce. The standard amount of fixed overhead per direct labor hour is $1, and the budgeted fixed overhead is $1,260. Our goal is to calculate the total fixed overhead variance and determine how the variance is split between the spending and volume variances. We begin with the actual fixed overhead, which should be given somewhere in the problem. And indeed, we see here that the actual fixed overhead costs were $1,260. The next thing we need is the budgeted fixed overhead. This should also be given, sometimes in the form of a flexible budget. We see here that the budgeted fixed overhead is also $1,260. The difference between the actual fixed overhead costs and the budget is called the spending variance. In this case, we can see that the actual and budgeted fixed overhead are the same, meaning there is no spending variance. Fixed overhead costs are oftentimes relatively easy to predict, such as rent or salaries, which can lead to the fixed overhead spending variance being small or non-existent. Next, we need to calculate the applied fixed overhead, which is equal to the standard hours, SH, times the standard fixed overhead rate, SFR. The standard hours are the amount of hours that should have been used to create the number of picnic tables that were produced. The standard hours can be found by taking the standard of 2 hours per table multiplied by the 540 tables that were produced, which equals 1,080. This can be multiplied by the $1 standard fixed overhead rate per hour to get $1,080. The difference between the budgeted fixed overhead and the applied fixed overhead is the volume variance. 1,260 minus 1,080 equals a $180 unfavorable volume variance. Remember that a volume variance occurs when the company operates at a different capacity than originally planned. So what does the difference between the budgeted fixed overhead and the applied fixed overhead have to do with a volume variance? Well, the best way to see it is to look at this table, which is sometimes given along with standard costing variance problems, which we briefly looked at earlier. This company budgeted to produce at 70% capacity, which is 630 units, but actually only produced at 540 units, which is 60% of capacity. Since this company produced at under capacity, only 540 units, only 1,080 labor hours were budgeted. This leads to only $1,080 of fixed overhead costs being applied. Since the applied fixed overhead is lower than the budgeted fixed overhead, this means that the company produced at under capacity, which is why the volume variance is unfavorable. Finally, we can calculate the total fixed overhead variance, which is simply the $180 unfavorable volume variance, since the spending variance is 0. Finally, we can put together the variable and fixed overhead variances to get the total overhead variance. The total variable overhead variance is $60 favorable, and the total fixed overhead variance is $180 unfavorable. Since one is favorable and the other is unfavorable, we can subtract the two values. 180 minus 60 equals a $120 total overhead variance, which takes on the unfavorable label of the larger fixed overhead variance. Alright, that wraps up our example relating to standard costing for overhead. Join us in the next video where we will complete the journal entries related to standard costing.